All right, greetings, Saintsmen. So we're going to work on the next section in the Algebra 1 textbook here, which is regarding solving equations with variables on both sides of an equation. So let's go ahead and get our first example going. Example being 5p is equal to 24 minus 3p. So the idea here is that we want to get all of the variable terms on one side of the equation and all of the constant terms or something without a variable in it on the other side. What's going to happen here is we're going to want to make sure that we move over this term in particular, minus 3p. And the reason is this. If I were to subtract 5p over here, I'm going to have a 0. And I'm going to have to move this negative 24 to the other side. So I'm going to be able to do this all in one shot, as long as I'm just trying to isolate all my variable terms on the other side. So I'm going to add 3p to both sides here. What happens then is that it's going to make these two guys cancel out. And then the sum of 5p and 3p, of course, being 5 plus 3 or 8p, and that's equal to 24. Next step, go ahead and put that actually in black here. 8p equal to 24. I'm going to divide both sides, right? Because I need to isolate my variable. In order to do that, I have to undo multiplying by 8. So I'm going to divide by 8 on both sides. It factors out the 8s on the left, which gives us p, and it's going to give us 24 divided by 8, which is 3, and that is your answer. Okay? In order to check that's come up, all you're going to do is you're going to wind up going back to the original equation, and you're going to go ahead and substitute in that p, 3 for the p in both cases. So 5 times 3 is equal to 24 minus 3 times 3. I want you guys to notice something here, is that when I substitute in a variable, notice that I put the substituted value in parentheses, and I strongly suggest that you do that. That's going to allow you to, I think, make fewer mistakes. It's commonly done, and you can't have too many parentheses really ever. So 5 times 3 is 15, and then we have 24 minus 3 times 3, which is 9. And of course, we see that when you subtract 24 and 9, you get 15, and we have the exact thing on both sides, so it checks out. So in the events that you have to check, that's how it's done. The next example, we're going to solve 2 times the quantity 3n minus 4, and that's going to be equal to 0.5 or 1/2 times the quantity 10 minus n. Okay, so a couple ways to go about this, of course. Yeah, I could divide by the 0.5 on both sides, but then I'm going to have to distribute after that. In this case, I'm actually just going to distribute from the get-go. I'm going to distribute from the start, okay? When I do that, it's going to yield the following. So when I have outside the parentheses, you guys see I make those distribution lines. It makes it so I don't make the mistake of not distributing to the second term. So in other words, 2 times 3n is 6n, but it forces me to do the step of 2 times negative 4, which is negative 8. And then I have 0.5 times 10, or in other words, half of 10, which is 5, minus 0.05 times n. If you so choose, you can actually make that 1/2. It's up to you. It doesn't matter. Okay. And then I need to move all my variable terms on one side and all of my constant terms on the other. So this guy being a variable term, I'm going to add him over to this side. So I'm going to add 0.05 n. Okay, so those guys are going to cancel out. 6 times 0.5 is 6.5. Sorry, 6 plus 0.5 is 6.5. n minus 8 equal to 5. And then I'm going to add, of course, 8 to both sides, so I can get the constant term, and I have all my variable stuff, all my variable terms consolidated on the left, which is 6.5n, and then I have all the constants consolidated on the right, which is 5 plus 8, which is 13. Okay, now we need to divide, and I'm hoping for you that this is a relatively straightforward problem to solve. So this is what n is equal to. The 6.5 is factor out. But how many times does 6.5 go into 13? And the answer in this case is 2. So just to check, two things. One, 6.5 times 2, right? 0, carry the 1. And then 6 times 2 is 12 plus 3, right? And then I have this decimal that I have to put the decimal point over here, right? The 1 decimal. So it's 13. That works. The other thing we can do is we can go back and check, okay? You can go back, plug in your 2, and see that the answer is what it is, which is 2. Please make sure you circle your answers. Next example. I have 4 times the, oops, let's go ahead and do that in black. I have 4 times the quantity 3d minus 1, and that's equal to 12d. So again, you guys see those parentheses. I hope you have the instinct here that you should be distributing from the get-go, okay? So 4 times 3d, right? Anytime you see that coefficient outside of the parentheses, there should be an instinct, let's distribute. If I can't go and then just divide on both sides, which I could also do that. I could divide both sides by 4. But in this case, I want to demonstrate something here. I have 12d, right? Once I distribute, 4 times 3, 12d, and then 4 times negative 1, which is negative 4, and that's equal to 12d. Now remember, I need to get all my variable terms on one side, so let's go ahead and subtract this guy off, right? So then I have the negative 4 now by itself, but watch what happens. If I take 12d and subtract 12d, I'm going to get 0. Gentlemen, negative 4 is not equal to 0. That does not make any sense, okay? This is not true. So because that's not true, this means that there is no real solution. And I want you guys to identify that way. So anytime that it does not make sense, it doesn't compute. The other thing that we would have done is if we divided by 4 in the beginning, we would have had 3d minus 1 would have been equal to 3d, right? And then again, subtracting my 3d, I would have had negative 1 is equal to 0. It's the same conclusion. That's not true, right? So that would have also yielded the same conclusion, as that there's no real solution. Next, we'll take the instance where we have 21 minus 7w, and that's equal to 7 times the quantity 3 minus w. And again, what do we see? We see parentheses with a coefficient outside, coefficient 7, and we're going to distribute inside of the parentheses. So I have 21 minus 7w, copying that back down, and then the result of our distribution, 7 times 3 is 21, and then 7 times negative w is negative 7w. Gentlemen, I think you see already what's going down here, right? We have an identity on both sides, but just to really solidify it, let's move all of our variable portions over. So I'm going to get rid of the 7w, right? I'm going to add that over, but when I did that to the other side, it wound up canceling out, and I get 21 is equal to 21, which is just a fact. It's true. When we have this identity, right, it's verified. It means it's exactly what we're looking for on both sides. What the conclusion is that there are infinitely many solutions. This is your answer. I want you to make sure that you write it as infinitely many, not infinity. Infinity is a different idea. Infinity means that infinity means never ending, right? It's not a number. It's an idea, right? So it's and then it's not all real solutions, right? It just means, because that means any number could work, and that's not what we're saying here. It means just that there's an infinite number of solutions that we can put in there that are going to wind up working out. So that is the results with the identity. All right. Our last example for today, because it shouldn't actually take us very long here. All right. we're going to have that Paul bikes for, I'm going to go a little bit larger, Paul bikes for 3 hours to reach his favorite beach. It's probably a good day for that today. He bikes 2 miles per hour faster on the way back. So the trip back takes only 2.5 hours. How fast did he bike going to the beach? All right, so this is our model here, and it's going to work like this. We need to make sure that we set up what's going to happen. So it's this is one of those things where he's commuting. He's going from home to beach and beach to home. So it goes that there's something you're going to know, which is your distance to the beach is going to be equal to the distance back home. If you guys recall, what you should have learned is that when you have distance is equal to a rate times a time, okay? So we need to figure out what his distance to the beach is. Well, we know that he took some amount of time, right? Here, and he has some rate as well. We don't know his rate of speed when he goes to the beach, so that's just going to be r. But we do know his time, which is 3. When he goes back home, we do know something about his rate. His rate increased, right? By how much? Well, it says by 2 miles an hour, so it's going to be r plus 2. That's his rate. And then his time, in this case, is 2.5 on the trip back, okay? Now, okay, right, because the distance is equal to the distance, so it's rate times time is equal to the rate times the time. I'm going to rewrite this guy just to reorder these variables. So I have 3 times r times 3, or 3r, and then I have a 2.5 being multiplied times r plus 2, in which case I can distribute. So I have 3r is equal to 2.5r plus 2.5 times 2 is going to be 5. Next, I need to subtract. I just reread the things. How fast did he bike going to the beach? Make sure that I, give the proper punctuation there. It's a question. I need to collect all the variable terms on one side. So I'm going to move over this 2.5r. Not p, it's r. So now that coefficient, or that constant term, 5, is by itself. So I have 5 over here. And then I have r minus 2.5r, which is 0.5r. I don't know why I keep writing p, r. Or 1/2. Okay? So it just depends on how you like to think about it. Now I'm going to divide in this case by 0.5. 0.5 divided by 0.5. And I think some of you guys may convert that to half, and that's fine. It's going to yield the same exact thing. So r is now by itself. Now remember, if I'm going to do this division, I have 0.5 going into 5. I got to move over, right, the decimal. So this is like 5.0. I got to move over. Okay, 5 goes into 50, 10 times. So r is equal to 10. In other words, the r is what this is. This means the rate to the beach. So our answer is 10 miles per hour, which you can abbreviate if you'd like. But that's how we solve this guy algebraically. For the record, for some of you guys who saw 0.5, right, and you wanted to write 0.5 as 1/2 and say 1/2 r is equal to 5, it's going to get the same thing, right? To get the r by itself, I multiply both sides by 2, get that guy to factor out. It's like 2 over 1, so it's, the r is by itself now. So r is equal to 10. It's the same thing, okay? Just remembering again, the key here, distance is equal to rate times time. If our distances are the same, our distance to the place and our distance back, if our distance upstream or distance downstream, our distance up the mountain or distance down the mountain, right? They're going to be equal if I start and stop. If I start in the same place and end, and then if my ending is also my beginning, if they work as a commute. If you have questions, feel free to ask them in the chat. And if you have any other concerns, also feel free to email me. Go ahead and get started on section 1.3. Good luck.